Good morning. Wasn't going to make another video, but decided to just to explain a little bit about the switching power supply and my experimentation on it. It's been suggested, and I think one of my viewers was a little mistaken. He's saying you're measuring across that cap 158 volts or whatever it is, and he says you're reading RMS voltage. There's no such thing as RMS voltage DC across an electrolytic. There is ripple across it, but we're not talking about AC voltage, we are talking about the DC. So the DC voltage across that 47 microfarad, which was replaced and originally was a 33 at 400 volts, I since changed it to a Nichicon that I had on hand, 250 volts, and I'm reading 147 volts DC across that capacitor, and 158 volts when the dehumidifier is turned off. Okay. The capacitor that I had in there, the 47 microfarad, 450 volt cap, had the same voltage on it, of course, DC. And the ripple AC component was 5.5 volt, 5.4. It's almost 5.5 volts ripple AC across that cap. And it was running just slightly lukewarm. I took it out. I have a blue ESR meter here, which I've had for a few years. The ESR read, offhand, I'm going by memory now because I don't write things down all the time. It did not change, even though it had that AC component on it, and it was running very lukewarm. That's the 450 volt electrolytic. The ESR was, and I'm going from memory now, so excuse me because I could be way off, 0.5 ohms, thereabouts. Okay? I have 3 or 4 other 47 microfarad 450 volt caps, brand new, that I pulled out of my drawer and compared the ESR. And believe it or not, the ESR was a couple of points higher on the other ones than it was in the run that was in here. But so close that it was still good. In other words, what I'm saying is, because it had 5.4 volts ripple on it, on a 450 volt cap AC, and it was running very slightly warm. I left this on all night. Dehumidifier was going all night. It's about half full right now. It didn't damage the cap. However, in spite of what anybody says, you do not need a 450 volt cap in there. Now, however, one of my other viewers pointed out that these power supplies are made to go on 240 volts. Okay, that's fine. There, you will need the 400 volt cap. Okay? But here in the US, we're getting 115, 117 volts, maybe 119 here. Okay? So you're not going to get much more than 160 volts DC across that cap. Okay. So with that said, I substituted a Nichicon, and I got to get on the bench here because I don't remember. It's a 250 volt electrolytic. That's what's in there right now. I just put it in about a half hour ago, off camera. So I'm going to go to the bench now And let's check. Now, I have an infrared thermometer, of course, that I can check the temperature. But it's only lukewarm, just very slightly lukewarm. I have to take the back of my fingers and feel it like that. So, it's nowhere near 105 C Celsius crap, whatever, but that's what they rated at. So I don't know what the Fahrenheit temperature would be, but I can guarantee you that it is not that hot. You know, it's not hot at all. It's just barely warm. So let me take you over to the bench, and I don't want to keep on going on this thing all the time, but it's a learning experience for me too. Okay, so let me take you over there. Hang on a minute. All right. Now if I don't knock this camera over here. Okay. Here is a Nichicon that I put in here. And it is warm, just as warm as the 450 volt. So I don't recall what the capacity is on this. I recall, I think it is a 33 microfarad. Like the original one was 33 microfarads, 400 volts. Now, as one of my viewers pointed out, and I totally agree with him, that the reason they use such a high voltage cap off the rectifier bridge from the line input is because when you run this on 220, you're going to need that voltage. But here in the US, we're only running on 120. Well, the average household would be 120. We are about 116 here, but we don't get good line voltage, and there's no ACs on. But anyways, okay, so this transformer is just barely warm. The heat sink over here is very hot, and I could add a piece of heat sink over here, but why should I screw around with this thing? It's out in the open air, naked, so it could run the dehumidifier just fine. It's better than being in this plastic case. So this is a tiny bit smaller, about the same diameter, but a little shorter, so I can push it up in there, but I'm not too worried about it because I'm not going to put this in a case. Matter of fact, I threw the case out into the recycle bin yesterday. As for the output, Jim Asbell pointed out that the toroid coil, let me see if I can get you a little closer here without knocking everything over. I'm going to have to handhold this, I'm sorry. The toroid coil here, Jim was saying something about, and I should have wrote it down. I put this cap here on the outside. Okay, even though the caps are in parallel, these two caps that I pulled out of here were in parallel, 1,000 microfarad each, which, by the way, I looked through, I don't have any 1,000 microfarad caps at 16 volts or any other voltage. I just don't have any. So I was going to stick, Jim had said, if I understood him correctly, that to put a cap in here because it's before this choke. Common mode choke or something like that. I hope I didn't misquote him. So maybe by putting a cap in here, but I just don't have anything. The caps I have are under 1,000 microfarad, way under. I don't have any. You saw all the caps I had in those little packages, and I just don't have them. And I'm not going out to buy anything. Some people told me to go out and, you know, you can order this or that. I'm not doing that. I've got a lot of caps on hand. And the cost with the shipping and buying caps for this thing, I can go out and buy 2 or 3 of these things by the, you know, on eBay or something. And in thrift stores, they just don't have 9-volt power supplies. They're all 5 volt for cell phones, 5 volt for tablets, They just, in our area, you're not going to get them. You might find a computer power supply, but the lowest voltage that would put out would be about 18 volts, maybe 12 volts. No good. So, all right, so I can't do nothing with this, so we got to stay with the 3,300 microfarad right here, okay, which I don't think is running warm at all, but this one, very slight. However, you put my meter on, 148.5 volts DC. So don't talk about RMS, because RMS, we're measuring DC here. The RMS coming off the line, yes, the peak voltage and so forth, but the rectified voltage, as long as the DC voltage does not exceed the capacitor you got on here, you are safe. However, there's a ripple on here, and the ripple increases substantially when I use the dehumidifier. The ripple drops off to almost nothing when I put when I turn off the dehumidifier. So what I'm going to do now is I'm going to get my Fluke 73 here, because this is measuring DC. I could set that. Let me see. This is automatic, so I'm not sure how to set that to AC. I'm not sure. It's all automatic. It's reading a DC voltage right now. See the icon on the left-hand side? Okay, so let's turn this on. Now, before I turn the camera on today, I'm getting millivolts through here now because it's not connected. I'm going to clip this on, these leads here, okay? I was getting about 7.5 volts ripple with this Nichicon in here. Maybe because it's a lower DC voltage rating, I don't know. So here's what I'm going to do. I'm going to put you back on a tripod. I'm going to aim the camera at the Fluke 73, which is set for AC right now, okay? And I'm going to tell you, you'll have to take my word for it, when I turn the dehumidifier on and when I turn the dehumidifier off. And you'll see the AC component or ripple that's across that electrolytic. So what I'm going to do now is I'm going to bring two leads over from here to here. So we're measuring both the DC voltage and we're measuring the AC component across the capacitor. Now I don't know why the ripple goes way up when the dehumidifier is on, but we are going to find out. Maybe we won't find out, but at least I'll show you what it is doing. Hang on a minute. Okay, 7.6 volts, that's varying, 7.8 AC, volts AC, you can see it, across the electrolytic. You have to take my word for it. I got 148.9 volts. I just went up to 149 DC across that electrolytic. We're talking about the Nichicon that I put in here now, the main filter. Now I'm going to turn off the dehumidifier. Dehumidifier is off. There is your ripple without the load on the switching power supply. Okay? That is directly off the electrolytic, and I am now reading 160 volts. Exactly 160 volts across the electrolytic. And this is the ripple content AC, which you're looking at right now. And now I'm going to turn the dehumidifier back on again. Dehumidifier is back on. There's your AC component over 8 volts now. Now, it was 5.4 volts, or 5.5 volts approximately, when I had the 450 volt cap in there. So, that might be why the cap is getting a little warm. However, there could be, I didn't put a scope on it, there's probably some all kinds of wicked sawtooth and everything else across it. If I don't have the room, but in experimentation, I could throw a disc capacitor across this. Maybe it'll knock the ripple down. I don't really know. But it's not good to have AC across an electrolytic, although it's under 8 volts. Might as well say 8 volts approximately. So this is what I wanted to point out to you on this thing, and this whole thing is an experimentation in progress. I don't like to drag on to one subject all the time. It gets boring. I know, sometimes, you're watching a YouTube channel and somebody's doing one thing constantly, and it can get boring. So I don't want to be, my videos are boring enough as it is. However, it's a learning curve for me, as well as maybe some of you out there that are not familiar with this stuff. And I'll be the first to tell you, I know very little, if anything, about this. I've read about switching power supplies, but it can go in one ear and out the other. I have a difficult time absorbing things. I always did, even when I was younger. There's some things I can grasp onto really well. Others, no. And when it comes to a complicated, and to me this is complicated, to some of you guys that grew up in the digital age, it's nothing to you. I grew up in the analog age, the best age, by the way. The vacuum tube era. I'm as old as dirt. Okay, so we're reading 147.2 volts DC and 7.9 volts AC ripple across the main filter cap. I will turn the dehumidifier off right now so we can verify it is off. We're reading 0.03, 0.05, it varies all over the place. AC ripple across the electrolytic. Okay, let's stop the recording for now. Okay, this is this little pocket digital oscilloscope I bought a while ago. It goes up to 5 megahertz. Very complicated to use these oscilloscopes. This is the one. Anyways, that is reading the AC ripple across the electrolytic while the dehumidifier is on. Now, I can't go by this thing because it's very, very confusing to use. I am much better using a good old analog oscilloscope. Digital scopes are extremely difficult to use. Believe me. Especially trying to figure out the settings here. Now, I was getting roughly around 8 volts across, AC across the electrolytic with the dehumidifier going. Here I'm reading 25 volts, if I can read that correctly, and 120 cycles. Yeah, that would sound right. Now if I turn off the dehumidifier, that's what we get. Now remember, we're reading AC. If you look on the top of the scale, it says AC. It's on auto. To be honest with you, it's very hard with it's reading, what is it, 20 milliseconds? The scan rate, I guess. So, anyways, I've got a 10x probe set on a 10x position here, so we don't damage the oscilloscope, because we have a DC across that capacitor of about 160 volts DC. So we'll put the thing back on here again. We got the dehumidifier back on. It took me a while to try to get anything on this scope here at all, and there's instructions, but they're very hard to read and they're microscopic. So anyways, that's what we're getting across it. Now, I'm feeling the electrolytic, and it's very, very, very slightly warm. It's almost neglectable. It's not really anything to worry about. As I'm sure these things get a lot hotter in the cases. We almost burn your hand on them. So that's the story there. I just figured I would show you, and now I'm going to try, and I know this is not going to be easy for me. Let me back this out, zoom out on the camera. Must have it on the slow zoom here. It's awkward for me to work. All right. Now, I have to fumble around with these buttons here on it. Now, I like my analog scope, but I figured I'd drag this out. Now, let me see now what we can do here. Get the magnifier to see what I'm on. What is that, 20? Yeah, 20 milliseconds. All right, let's set that to 10 milliseconds. That's the scan rate. 100 volts going in, reading roughly 27 volts AC, 120 cycles. So that's the ripple. Now that's with the dehumidifier going, but I am reading, if this is 27.5, so that is obviously, because we're reading AC voltage now, yes, you are going to have a peak-to-peak, but you will not have a peak-to-peak on DC. No such thing. All right, so the meter, the Fluke 73 read approximately 8 volts, okay? Obviously, this is peak-to-peak. That's fine. Scopes will read peak-to-peak. Scopes do not read RMS. They'll read peak-to-peak. Okay? That I know. All right, so let's bring this down to... what did we bring it up? No, we brought it up. Let's bring it down. Okay, there's your ripple. Hey, let me see something here. I'm going the wrong way. Trying to get the voltage to read better. There it is. She's reading too high. Let's up that down a little bit. You know, I like a good old analog scope because here you got push buttons and, you know, where you don't have a control, a vernier control. Of course, you would have it on an expensive digital scope, but you wouldn't have it on this. So we just have to do with the click methods on the push buttons. But that's, now we're not reading any frequency now. So I really don't know what's going on, but we're reading 0 cycles per second, or hertz for you new guys. And just push it over here a little bit more, and no, we're set too low here. Let's bring it up back. Still reading 0 frequency. Probably because we're not locked in. Let's jump this one more time here. We're still reading the voltage, but we're not reading any frequency. So, you know, what I do on things like this is I use a frequency counter. It's so much easier just to slap a frequency counter on it and you'll get your reading. Now, however, I have used this scope on signal generators and it will read the frequency. Like if I set the frequency counter to 455 kc, for instance, and then I slap the scope on it, it will read 455 kc, but you got to have the input voltage set right. The input here, I think, is 50 volts, and I think that's the 50 volt, in other words, peak to peak, 50 volts per division. That's what I wanted to say. Okay, so anyways, we're not getting any frequency on it at all now. We're not getting that 120 cycles. But enough of that. Okay, we are back on. And we're going to run it this way for a while. Unfortunately, I don't have any 1000 microfarad of any voltage that could go in here. So good enough. We'll leave this on there. Nothing else I can do. I have much smaller capacity that can go in here. You know, but that's probably going to do nothing. No big deal. So I kind of like showed you my inexperience with digital oscilloscopes. They are very, very confusing. And to me, give me the analog any day. Thank you very much for watching. You take care, everybody. Have a good day. Sorry to bore you with another electronic video. But it's better than me flapping, isn't it? I think so. Take care, everybody.